morning all. So I did my research on distributed protocol using quantum cryptography for secure communication in ad-hoc networks. So under the guidance of R. Vivekananda, Professor, Department of Computer Science Engineering. So nowadays most of the government organizations and different associations working with banks are making use of cryptography to enhance the security issues involved in the communication. So every mobile communication we take, there the major issue is communication with security. So if security is not provided properly, then there are some possible attacks. Those are active attack, passive attack, internal attacks, external attacks, backhole attack, wormhole attack, etc. So because of these attacks, data loss in communication and packet loss in communication will take place. So in order to overcome backhole attack, we proposed AODV-DRSA QC method, which effectively reduces backhole attack. So in these backhole attack methods, when there is a root, it will check the threshold value of that node, and if that node consisting of more threshold value in terms of its energy, then only the packet is forwarded. Otherwise it will reject the path and the previous node will search for other node where enough threshold energy is there. So in this way backhole attack is avoided this way. Here from source to destination B, the path is selected, that is requested, and because if the path consisting of enough energy, the request may be forwarded. As of now in this, B is having backhole attack, so as it is not having enough energy, the request is rejected. That means in terms of response or REP, that is sent back to source, and source will select one more path in slide number 5 and in slide number 6. So in this case, in AODV method, cryptography is making use of keys, private keys at both parties, source and destination, and based on these private keys only security is provided. And meanwhile it also making use of AODV for routing purpose. Quantum cryptography works based on the principles of phase shifting operation and SK distribution operation, which will enhance the security of packet transmission with the minimum overhead. Quantum cryptography basically employs the shifting operations in order to provide this security between these two parties, source and destination. And in quantum cryptography, basically the working procedure is like this. Like source will send a plain text which is encrypted with the help of shared key, and then quantum state generator, which make use of communication channel to send the encrypted data, and again at receiver side, destination side, quantum state detector will take the data from communication channel, and the same shared key is applied and decrypted and get the plain text. In my proposed work, AODV-DRSA cryptography methodology, it makes use of dual RSA algorithm to provide security for the shared keys. Shared keys are given to dual RSA, and then those are encrypted, and those keys are used in this decryption and encryption process. And the flow is like this. When mobile node deployment is over, transmission of data packet and quantum cryptography is applied. Quantum key cryptography based on dual algorithm is applied. Then encryption taking place, and at receiver side, AODV algorithm is taken to find the root, and then detection of black hole attacks are taken place with the help of algorithm which we mentioned just now. And finally, the data is decrypted at the destination side. And to perform this work, in my proposed work, AODV-DRSA quantum cryptography method, it results in throughput, number of alive nodes, number of dead nodes, and energy nodes. These are the basic factors we have considered to propose our work. And then after simulation, before getting to simulation, we have considered some of the simulation points, like how much area we have to take, how many number of sensor nodes, and what is the initial energy of the node, and then length of that iteration, like how many rounds it is going to work, and then what is the range of communication, and then packet size and message size. These are the basic parameters considered for our simulation. And then our simulation work is better than the previous one, which is AODV QC, quantum cryptography, where they have not applied this dual RSA algorithm, and by applying that one we got more enhancements in alive nodes, dead nodes, energy consumption, and throughput. These are some of the figures, and then this will show you how our method, which is in blue line, works better than the previous one, which is AODV quantum cryptography. But now our work is AODV DRSA QC, and then this is about dead nodes, and this is about energy consumption, which is far away from the previous one, which is very good. And in quantum cryptography nowadays, this will provide more security than previous one. Here we make use of quantum decimation, which is more useful to provide security between sender and receiver.